All right, I'm back. Sorry, it cuts me off. So I left off talking about significant figures and why they're used and all that. Now I want to talk about how they're used in calculations. So it starts off explaining rounding rules, which are the same rounding rules from that you've known your whole life. So if the number is less than or equal to 4, leave it alone. If it's greater than or equal to 5, round up. For multiplication and division, so this means I'm going to multiply or divide two values. What this is saying is that the answer that you get needs to have the same number of significant figures as the value with the fewest significant figures. So in the example here, you see 56.8, which is 3 significant figures, times 0.37, which is 2 significant figures, because this is a leading zero, it is not significant. You type that into your calculator, you're going to get 21.016. But because I'm multiplying, my answer can only have the same number of sig figs as the one with the fewest. So that's 2 significant figures. That means I need to round my calculator answer to only include 2 significant figures. All right, that's multiplication and division. Next is addition and subtraction. Same concept, and I'm adding or subtracting. The answer is going to have the same number of digits past the decimal as the one with the fewest. So it's not total significant figures, it's places past the decimal. So here's the example, 2.045, that's 3 places past the decimal, plus 34.1, that's 1 place past the decimal. If I type that into the calculator, I'm going to get 36.145, which I know I have to round to only include 1 place past the decimal, and that's 36.1. And this is the example I use the most to explain why significant figures are important. So we added these two numbers and we got 36.145. The problem with this last 4 and 5 is that we don't know that those are the true numbers that go there, because we don't know what comes after this 1. Is it 0, 0? Is it 1, 1? But we just don't know for sure. So because we don't know the digits past this 1, we don't know the 4 and 5 for certain, which means we have to cut them off and only include the 1 place past the decimal. This is for all addition and subtraction. All right, next is writing conversion factors. So I kind of use these two terms interchangeably. Your book is going to call it an equality, which is just like this equals this. It's the same quantity but different units. 60 minutes equals 1 hour, for example. And then conversion factor, same as an equality but in a fraction form. Again, like I said, I use these interchangeably, and you can write it either way. So what you're going to see as we go on in the semester is we can put the unit that we need where we need it, so it can be on top or bottom, okay? Because we're going to be able to cancel them out as we go. And it says, remember, numbers, inequalities, or conversion factors are exact, meaning it doesn't matter that this is 6, 0. We don't care that it's 1 significant figure. That's not included in our determining the number of significant figures. So that's that. Problem solving using unit conversion. So this is kind of a core chemistry skill that you're going to use all semester long. That's why it's underlined in red. You're going to start with what you're given, use a conversion factor to get to the unit that you need. And here are my tips there. Next, you will see density, which is mass over volume, grams over milliliters, and just some simple facts about density. So I'm going to stop there. This is just an overview. I'm going to go over certain problems and post them like I showed you in the other video. So that's that. Let me know if you have any questions. See you next time.